Welcome, everyone. I just see a few people are hopping on to the stream right now, so I'm just going to give it a couple of minutes here for folks to join in and everyone to get connected. So we'll just, if you're here already, I'll give a few more minutes and then I'll kick things off.
Hey, do you want to test your audio real quick?
Hey, Audrey.
Hi. Did you want to test your audio real quick?
Yeah, sure. I think we're live right now. Just a heads up. But yeah, I tested with Alex. So I think we're all good. So for any folks that are just streaming in right now, I'm just giving it about one more minute and then I will kick things off. So just making sure people are able to join here. Okay, we're about a couple minutes past here, so we'll kick things off. Welcome, everyone. This is our first live workshop. We're going to be going over some IoT hacking 101 today in this live workshop. This is going to be part one of a two-part series, so the next one will be in 2 weeks. I'll just quickly start with an introduction for anyone here that doesn't know me. So I'm Andrew Bellini, and I go by Digital Andrew on the social medias, including the TCM Discord. I am an electrical engineer, so my background is in electrical engineering, and I now actually work as a content creator at TCM Security. I am the creator of the TCM Security Beginners IoT Hacking and Hardware Hacking course, and I'm also the creator of the Practical Junior IoT certification. And if you want to link up with me, you can reach me at andrewbellini.com. So just a very quick agenda of what we're going to go over today. We're going to start with just a few really quick housekeeping items, and then we will jump right into setting up the Raspberry Pi that we're going to be using. So some of today's session, or a large portion of the session, is just going to be teaching you how to set up the target device that we're using, which is that Raspberry Pi Zero, and how to load the custom firmware that I've written for us to test with. But I'm going to do a primer on soldering. So the Raspberry Pi Zeros that we are using in this course, they don't come with the header pins that we'll need to be able to interact with it. So we're going to need to solder that unless you went ahead and purchased one of the pre-soldered versions. So I will quickly show how to do that. We will then go over what UART is, which is going to be the primary way we're going to interact with our Raspberry Pi. We'll talk about how to identify it. We're then going to learn about how to use a logic analyzer. And then after that, we'll actually go ahead and get a shell into the Raspberry Pi using the UART connection that we identified. And then at the end, I will take some time. I'll have about an hour, actually, if anyone needs help, to do a wrap up and some Q&A. And then also at some point in the middle of this lesson, I will take a 10-minute break. So if anyone is waiting and needs to go to the washroom, you don't want to miss anything, then go ahead and we'll have that 10-minute break that anyone can use. So I'll give a heads up when that's coming up as well. It'll be somewhere around an hour and a half from now. We're planning on doing about 3 hours of lesson today, and then 1 hour afterwards for Q&A. Okay, so before we do dive into anything else, I just wanted to go over some really quick safety items. So there's two main things I want to talk about. So the very first one is just so that no one gets into any trouble. Of course, this TCM Security, we are an ethical hacking company and we teach ethical hacking. So that's what I wanted to cover first in our kind of like safety discussion. So this is just to keep yourself safe from the law. So the very first thing is that we should only test devices that you own or are authorized to. So in this course, we're going to just be using the Raspberry Pi that hopefully you bought or is your own. And we're going to be using the firmware that TCM created for learning. So just the golden rule here is just be ethical. And if you do go out and you are deciding to do testing on real world IoT devices and you do find a vulnerability or something, then I always encourage to follow responsible disclosure. Okay, so now the second safety item, since we are actually going to be doing a bit of hardware hacking today and work with hardware, is we should go over some basic electrical lab safety. So the very first one, and if there's only really one thing that you take away, is that we should never work on high voltage. And what I mean by that is the voltage from our outlets in our household. So everything that we're going to be doing in this workshop today is very inherently safe. We're going to just be working with the power that is on the Raspberry Pi itself, which gets powered through USB. So the maximum voltages is going to be at 5 volts or 3.3 volts, which are very safe levels to work on. So if you just only take one thing away, it's that we shouldn't be touching anything or using anything we learn or the equipment on the outlets or the electricity for our house. We'll just use the power that's on the Raspberry Pi itself. Second point is we should never use damaged or modified power supplies. So if you do have one that you see is damaged, or sometimes people will modify them in any way, this can then introduce that higher voltage to our test equipment or into the Raspberry Pi itself and make it dangerous. So we should never use those. And then this is just a really good rule of thumb for keeping your equipment safe, is that we should power off the circuits when we're not using them. This is going to prevent us from doing any shorts or causing damage to them. And it's also a really good safety practice just to keep in mind. If you are feeling nervous after seeing like a safety thing or anything like that, though, just a heads up that everything we're going to be doing in this course is going to be inherently very safe as long as you don't plug anything other than your power supply into the outlet of your house. Okay, and then one other quick safety thing, we are going to be using soldering irons today for some people if they want the primer or they want to attach their header pins with their soldering iron. Of course, soldering irons are hot. That goes without saying. However, I'll raise my hand and say, like, I burned myself with a soldering iron before, or by touching something that a soldering iron touched and got hot. So just to keep in mind, anything metal on the soldering iron is going to be hot. So like the cage that holds it, there's parts that aren't the tip that are metal. Those are all going to be hot. And then anything it touches is going to get hot too. So when we're soldering our header pins in place for your soldering wires or things, those also get really hot too. So just keep that in mind, because I've done that before where I've tried to hold something that I'm soldering in place with my hands and the whole thing gets hot, you'll burn yourself. Second safety item here is that solder is generally made of lead. So you should wash your hands after touching it. And we should also use a fume extractor or good ventilation. And then finally, I always suggest using eye protection when soldering. And I know this sounds kind of weird maybe because the soldering iron is like away from our eyes and gravity would say that all the solder would fall down, but solder and the flux inside of it can almost like splash in really weird ways. So I would suggest wearing eye protection because you really do not want to get like a melting blob of solder or flux in your eyes. Okay, so just one other quick housekeeping thing before we dive into the actual work today is if you do have any questions or comments here during the live stream, the best way to get in touch with me, or if you just want to say hi, so I encourage you, if you're streamed in here watching this right now, go say hi. We have a Discord channel set up for this. It's the Academy Live IoT. So that's the best way to get in touch with me. I can't see YouTube comments, so if somehow you're leaving YouTube comments, I won't be able to see them with the way that we have this set up. I can only just see in the Discord. And I'll try and check in here to these when we have some pauses or people have questions. But I will also set aside about an hour at the end if people are stuck or they run into any issues to go over this. And then one other quick thing too here is if you are watching, so you probably everyone's watching in the academy right now. So if I just bring mine over here to show you. So I've actually gone ahead as well and put all of the instructions and the commands that need to be run. So if you just scroll down below, pretty much every command I'm going to run is here, and you can just copy and paste it. So if you are getting stuck or you miss something, then go ahead and just grab them from here. All the links and everything, screenshots, it's all here. So just use that as a resource as well. Perfect. So I think that covers all of the housekeeping that we need to do right now. So what I'm going to do is I'm going to switch over to my virtual machine, and we will go over taking a look at how to set up our SD card and format it so we can put that custom firmware onto our Raspberry Pis. Okay, perfect. So the first thing we're going to actually need to do is, if you haven't done this already, is go ahead and I'll give everyone like a minute or two just in case it needs to download. And I'm just going to check the Discord while I do that, but I'll just bring this over again. So we're going to need this. The device is called the dumb thing that we're going to be working with right now. And this is the firmware for it. So it's in the Academy here. So go ahead and download this. And if you need to, bring it over to your Kali VM or whatever you're using. Bring it over right now. I'm just going to give about a minute for people to download in case your internet's a little bit slower. So go ahead and do that right now. Okay, perfect. All right. So hopefully everyone's got theirs downloaded. So I had to put it as a zip because otherwise Teachable thought it might be malware. So the first thing we'll just need to do is unzip it. So we'll just go unzip, and it should be that dumb underscore thing v101.zip. So we'll just go ahead and extract that. And then there should only be one thing in that, and that is a .img file. So that's what we're going to be writing onto our SD card. So I'll just clear this away. There's a couple of ways to write this onto the SD card, but the easiest way is to use some software by Balena called Etcher. And the easiest way to install that is if you actually just go into your course, the course here, and grab this wget command and the link. And I'm just going to actually copy it and paste it directly in here. And I'll just let this run through here, and I'll give a extra 30 seconds or so in case folks' internet connection is a little bit slower than me. Okay, perfect. So now we should have this zipped file. So again, we'll just unzip this. Perfect. And I'm just going to head over into that directory that we unzipped. And if we just list this out, we've got the actual binary here that we can run. So we can just run this with /Balena Etcher. Perfect. So you should get it popped up like this. And then what we're going to do is we're going to go flash from file. And then I'm going to select that .img file that we have, so the one that we unzipped. Just move this here and click open. Perfect. And then we're going to click select target. So before we do that though, going to need to put our SD card into our SD card reader and then plug our SD card reader in. So however you're doing that. So I got mine right here, my micro SD card, and I got my reader already plugged in. So I'm just going to plug that SD card in now. Perfect. And then what you may need to do if you're on a VM is you may need to actually just go. Hold on a second, my mouse is giving me some fun troubles here. All right, there we go. So you may need to go up and into your VM and then go to removable devices and make sure that it's there. So mine is this Genesis Logic USB storage. So I'm going to connect that, give it a heads up. And then we can choose our target. So mine is this 31.9 gigabytes. So that's the size of this SD card. Yours is probably going to be in this /dev/SDB. So one thing I will say with Blender Etcher is if your thing is not showing here and you see how it says show one hidden, and you see here it says like system drive, should never ever click that or touch these, because what that's going to do is that will write this image over your drive, like whatever your hard drive is for your virtual machine, or if you're on your computer. So stay away. That's dangerous. You can see it's even giving us a warning. So I'm going to select the one that I did right here. Is this generic storage drive. Select one. And then once I'm all happy with that, I got the right image and this, I'm going to hit flash. And depending on how you have your setup, if you're not running as root, you will need to have sudo privileges and then just put your password in. So I'm going to put mine right now and click authenticate. And then this will take maybe a minute or so to flash through. Perfect. So mine's done. So I'm just going to give like maybe a minute here though for everyone that's following along to make sure that theirs goes through, because sometimes what will happen too is it will fail, and that's okay. If it does, just go flash another, like click here, flash another, and then just select your target again and rerun the flash. Sometimes it fails on validating. I've had that happen quite a few times. So I'll just, give maybe another 30 seconds here for any folks that are following along and flashing their own. Okay, perfect. So the last thing we need to do is actually just make sure we safely eject this before you unplug your SD card. So the easiest way to do that is if you just open up your file explorer. So I'll open up mine. And then you should have these two drives here that are mounted. One is this 34 megabyte volume and then the root file system. So if you just eject one of them, then it should eject the whole thing. Okay, that's fine. So it says that it can be safely unplugged and the device can be removed. So now you can unplug it. If you don't do this or you didn't do it, it's not the end of the world, but sometimes the Raspberry Pi will get upset about it not being unmounted from the other device properly. Okay, so I've got mine out, and then what I'm going to do is I'll head over to my work desk over here and switch the camera, and we'll look at powering this up, just making sure it powers up, and then I will give a quick primer on how to connect your header pins if any folks don't have it. Or actually, we'll ask, is anyone going to be soldering? I'm going to just pop this into the Discord. If anyone's going to be soldering along today, just give me a heads up. I would like to just know. Okay, I see at least one person will. So I will go over then the primer for soldering and show how to attach these header pins. So I just got my camera over at my desk. I'm going to head over to the desk and we'll talk about a few things here plugging in. Okay, so I've got my Raspberry Pi here, and before we start handling them, actually, I just want to talk a little bit also about electrostatic discharge and ESD precautions. So ESD stands for electrostatic discharge, and it's probably something you've come across in your life, maybe in the winter if you were walking on a carpet and you went and touched like a doorknob or something and it shocked you. So for humans, it's, just kind of maybe a minor nuisance, but for electrical devices, especially small ones like this one, we've got really small components on here. If we were to discharge an electrostatic shock across them, there's a good chance that it can damage those components and then our whole machine won't work. So there's a few really basic and easy things that we can do without any equipment that are going to, um, for the most part, protect us from ESD. And these are things that I follow, like when I'm personally working on IoT devices or building computers and things like that. And I've never damage the device just by following them. So the very most important one is I just hold devices. You can see I'm holding this only by the edge. And if I'm going to point at things, you can see I've actually got this plastic tool here where I'll point to. And I would never go out and even I don't even want to bring my finger close to these devices because sometimes you don't even need to touch it. But if you were to, for example, this was my finger and go and touch these, that's a good way to actually deliver a shock into this. And then I'm also just using this mat as well, which is a electrostatic discharge mat. The other thing too is your Raspberry Pi probably came with one of these ESD bags, and these are great at preventing electrostatic shocks as well. So if you're moving around your device, you're storing it or something, you can just keep it in this bag, and that will help to keep it safe. Okay, so my Raspberry Pi, I've already soldered the header pins on, and then so um, it depends on how you bought yours. Some of them come without it. So what I'm going to do is I'll show how to actually attach these. And what I would suggest is today we're actually only going to be using the ones if you're holding it like this with the power on the left hand side kind of upright like this. We're only going to be using the furthest right strip. So what I would suggest is just solder that one in place. And even if you only just want to solder maybe the first, I don't know, 6 or so connections here, that will be fine because I'm probably not going to have time to wait for anyone that's soldering to do the whole thing. And then, later on in your own time, just finish soldering these in. So I'll just grab my header pins here. So these are the pins that are actually going to slot into those through hole connections. And since I've already soldered mine, I don't have one to solder. I've got this PCB board here, this test board that's for prototyping. It's essentially going to be the same though. We've got these through hole connections on here. It's going to be the exact same. So what I'll do is you can actually break these. So you'll want to measure it up to where you would want it to be. And then I kind of just hold it with my hands, or you can count them out. And they just snap. So I'm going to actually just snap a couple off though, because I don't want the whole thing. So you just snap those to break them down to size. And then they just slot through the through hole components. So you can just slot it through like this. And then what I'm going to be using is I'll use a third hand to actually hold these in place here. So I'll just bring that over right now. So I've got my third hand here. And then what I'll do is using the other clip here, I'm just going to hold these components in place. Perfect. And I've got them held in place. So I've already got my soldering iron on, and they do take a little while to heat up. So I did heat mine up already. And I've got my solder here. So I'm using this lead solder here. So what you want to do when you're soldering, the very first thing actually, so just a heads up, if you don't have them or if you're going to, I'm going to put on my safety glasses here. The first thing we'll do is we're actually just going to check and make sure the soldering iron is hot, and also do what's called tinning the tip. So I'll bring my soldering iron into focus here. I've got my iron here. Maybe I'll just zoom out a bit as well. So we're going to melt a little bit of the solder onto the tip of the iron. And this is called tinning the tip. So it does two things. One, it makes sure that we have this soldering iron hot enough. And then also two, it adds a little coating of solder onto the tip here. And it's going to make our lives a little bit easier to solder. So I've got mine tinned up. You can just see it's this little bit of solder on the tip. And then what we want to do when soldering is you want to touch the soldering iron to where we want to solder, and then we touch the solder to that heated up portion. So one thing that's tempting to do, and I'll just kind of like give a demonstration of it, is you're going to want to like maybe try and like glob the solder on like this, and that's not what we want to do. What we want to do is hold the soldering iron to the component, let that get hot, and then we touch the actual solder to that component. And here I'll just zoom in a bit so it makes it a little bit easier to see here. And I'll do a couple more here. So there's one on the end here that I'll do. And you can see I'm actually touching the soldering iron to where I want to heat up. And then I'm touching the solder kind of like just to that heated. I just hold it for a second and then bring it away. And I'll do one more here, maybe in the middle here. So I'm just holding that soldering iron, getting the area hot. And then I'm touching the solder to it and then bring it away. So that's a really important thing to remember. So I'll just like kind of like show a bad example here. What we don't want to be doing is like trying to get the solder and like touching it and melting it and then globbing it on. You see, like it just makes a huge mess. Now I've got like way too much solder. And what you can do there is get, this one actually is a good example. It didn't like properly solder on. So we've got what's called a cold solder there. And we can also get bridges. So one last time, just to kind of show the proper method, I'm heating up the pin that I want to heat up, and then I'm just touching the solder to that pin. And we've got some really nice solder joints right there. If you do want a little bit more of an in-depth kind of demonstration on soldering, there's also a video in the IoT hacking course, a whole like 15-minute video that goes over soldering as well. So you can go and check out that video as well if you need a little bit more details later on. So what I'm going to do is I'll just move this over to the side here. Yeah, just a quick reminder for anyone that's following along, just do the one side of yours. Just do, this right side here. That's all you're going to need. Okay, so let's now take a look at making sure our Pi boots up here with the new firmware. So I've got my chip here. If I can pick it up, it's my SD card. And I'm just going to plug it in. So the SD card reader is right here. And I'll plug it in, clip it in. And then to power the Raspberry Pi, we need a micro USB, and it goes to this one right here. And you can actually see it denoted with power in. We'll plug that guy in here. Okay, and then once it starts up, you should see a little bit of blinking for the green light, but then it should just go steady after about a second or two. Let's bring it up so everyone can see. And that's going to mean that our Pi is booted up and ready to go. So what I'll do now that we have our Pi set up is I'm going to hop back over to my computer actually, and we'll chat a little bit about UART. Okay, so the very first communication protocol that I usually teach when talking about IoT is UART, and UART stands for Universal Asynchronous Receiver Transmitter. So this is a very, very old protocol, and it's a very common one for electrical communication. It's one of the most basic ones, and you'll very, very frequently, almost always see it in some format on IoT devices and embedded devices. And essentially, it just uses pulses of voltage to transmit binary. So it's not even like actually part of the OSI modeler. It has nothing to do with that. But if you are familiar with that model, then you can kind of like think of layer one where we have the volts on the wire or the pulses on the wire. Well, essentially, UART is just that. It's literally we just send a voltage on the wire and we send a high. So we can see in this picture here, we've got, like, for example, when we want to send a 1, we just send a high volt or a high signal on the line. And then when we want to send a 0, we just don't send any voltage. And then there are some other parameters, of course, that we need to take care of so that we can actually decode this transmission on the other end. We'll chat about those, but at its very basic, it's essentially we just turn a voltage on and off to send binary. Okay, so UART itself, it uses 3 different pins that we're going to need to talk about. So what I'll do is I'm just going to draw those on the screen, and we'll kind of talk about how we can actually identify those. So if we just have 2 devices, so we can think of like device A here. And what I'm going to do is I'm just going to draw like a pseudo representation of a microchip here. And we'll call this device A. And then generally on microchips, like we'll represent the ins and outs with pins. We'll have 4 here. And then like there would be more pins on a microprocessor or something like that, but this is kind of a pseudo representation. And then we'll have device B here that we want to talk UART with as well. And we'll just make it has the same set of pins here. Perfect. So there's going to be generally 3 pins that we use for UART communication, and then one of them that's almost always never used, but you will sometimes see. So I'll show it. So those pins are VCC, and VCC stands for voltage of the common collector. That's essentially the operating voltage of the system, or at least the operating voltage of the UART. The next one is going to be TX, and TX stands for transmit or transmission. And then we're going to have RX, which stands for receiver or receive. And then we will have a ground. And then, of course, on our other device, we'll have the same connections here. So we'll have VCC, our transmit, our RX, and our ground. And one of the really nice things about UART and what makes it so basic is that it is a asynchronous communication and that there's no clock to synchronize. And we have 2 communication lines. So because we don't need to synchronize, we have those 2 communication lines. We don't need to worry about collisions or having any clear to sends or making sure the line is clear. But what that does mean, though, however, is when we're connecting these up, we need to keep in mind that the transmit of one device, so if this device wants to talk, so let's say device A, for example, is actually our Pi, that's our Raspberry Pi, and then device B, this is us on the other end trying to listen. Well, it's going to send out those voltage blips on the TX pin, and then we need to capture them if we are using a device to talk UART. Well, we need to capture them on the RX pin. So we'll talk out on that. And then when we want to talk back to the Pi, if it's going to be listening for UART, we need to come out from RTX and we need to go to the RX. So pretty straightforward. I do this myself sometimes still. It's really tempting when you see 2 things labeled the same, like TX and TX, that they should be connected together. So just, the only one really thing to keep in mind for UART communication when you're wiring it up is to make sure you're crossing your TX to the RX. The grounds will actually just get tied together. And the reason we do that is so that then we're at a common ground, and essentially, 3 volts or 5 volts or whatever we're operating at is going to be the same between the 2 devices. And then VCC is almost always just going to be a no connection. So that's NC, so it doesn't get used. So you don't actually need to connect these together, and you should not connect them together. Okay, so let's just talk about a little bit now, if we were to graph what was going on the transmit line here. So if I just draw a really basic graph here, just to show what we're going to be looking for. Down here, this is time. And then this over here is going to be volts. And we'll put this at 0 volts here. And then we can say this is going to be our VCC, which is probably going to be 3.3 volts. So if this Raspberry Pi was transmitting, then what we would see is similar to the other picture, something like square waves that look like this between 0 and 3.3 volts. And of course, this would be a 1, a 0, 1, 1, 0, 1. And the reason that I'm showing this and so that we can talk about it is because we can actually use this to our advantage if we are going to go out and try and find a UART connection on a board that isn't clearly labeled. So in our example, of course, we have the Raspberry Pi, which is open source, and it's very easy to find these connections. But if we're taking a look at consumer devices, sometimes they're not going to be clearly labeled or as easy to find. So what we can do with knowing this information is we can actually use a very basic piece of equipment that should be in every hardware hacker's toolbox, which is a digital multimeter. And we can try and identify pins that we think might be UART connectors on the board. And we can measure that's the TX pin here and take a look at the voltage and see if it's fluctuating. So what you're generally going to see is you can see here, like we're going between 3.3 volts and 0 volts. So we've got like going to have like some sort of like average that kind of comes up here if we were to measure the voltage. And if you're operating at 3.3 volts, which you'll usually see, that means that you'll see the voltage fluctuating probably somewhere between like 1.5 volts to like maybe 2.7 volts when it's transmitting. So what we're going to do, and we'll hop over to the workbench soon after we finish talking about UART, is take a look at how to actually identify that with the multimeter. So the other thing to keep in mind is that that is actually going to only be fluctuating when there's an actual transmission. And the best way to trigger that is to actually just power on the device. And similar to if you've ever powered on your computer and looked at all the messages coming out from your BIOS and the bootloader and everything, it's going to be actually the same for a Raspberry Pi and a lot of other devices where they're very, very chatty at startup. There's going to be a lot of logging going out onto the UART line of communication. And then after that, there will be very little. So it will be hard to see. So what you'll want to do is we'll take a look at is we would just trigger that communication by power cycling the device and then measuring with the multimeter. So just to give an idea of what this looks like on a commercial device, because my goal for this course is that we're using the Raspberry Pi because it's easier to get custom firmware on it and show vulnerabilities, but that you will be able to go out and take these things that you learn to other practical real life IoT devices. So I just want to show what this looks like. This is the router that we use in the IoT hacking course. So you can see here we've got these 4 pins and they're labeled for us, which is nice. But it won't always be that easy. So here's another couple devices. And sometimes they will just look like test pads and they won't be labeled. Or maybe we'll have some surface mount connections or test pads like this. And so this is why also we're going to be learning about how to identify them. And it may seem like really obvious on the Raspberry Pi because they're already labeled, but this is why I'm showing how to go and hunt these out with a multimeter and other tools, because it's not always going to be this easy. So of course, what we're going to be doing, and I'll hop over to the lab here in a second, the lab bench, is we're going to try and ID it with a digital multimeter. And of course, like I mentioned, the UART is very chatty on boot up. So what we'll do is we'll look for a fluctuating voltage on that transmission pin. And that's going to help us identify that it's a TX pin. And then generally the receive line, because we're just going to be sitting there listening on it, well, that line is going to either be a steady 3.3 volts or 0 volts. And then we can find the ground. We can really use any grounds, but we can try and infer what some of the grounds are if we don't know, and we can use continuity to test those. So I'm going to hop over now actually to our workbench, and we'll take a look at how to use the multimeter to check for that fluctuating voltage. I'm just seeing your soldering picture now. Okay, so I've got my multimeter here. And the nice thing about these multimeters is they're kind of like the Swiss Army knife of the hardware hacking toolbox, and that they allow us to make many measurements. And yours may look a little bit different, but generally they're all going to have similar functions on them. This multimeter isn't auto ranging. So what that means is we have to choose the range, the operating range that we want to make our measurements at. So that's why there's so many different options along here. And what we're going to be doing in this lesson is we're actually just going to be taking a voltage measurement. We're going to be doing a DC, direct current voltage measurement. So on this meter, that's all of these measurements over here. When we've got this V with this solid line and this dash dash underneath, that means that's a symbol for direct current. And you'll see here we've got these different ratings here. So we've got 200 M, 2000 M, 20, 200, 500. So essentially the way that these work in auto ranging is that this is for 0 to 200 millivolts. This one is for 0 to 2000 millivolts. This one is for 0 to 20. This one's for 0 to 200. And this one, or sorry, I shouldn't say 0. It's always from the one before. So this one's 0 to 200. This one's 200 to 2000. This one is 2000 millivolts to 20 millivolts. This one is 20 to 200. And this one's 200 to 500. The other thing I will show is if you just bought this multimeter, or you have a different one and you haven't plugged in, these are called the probes here. So these that plug in. You'll notice we have this one here that's called COM. That's for common ground. So that's where the black one's going to plug in. So I'll just show what this looks like here. So make sure to plug your black one into the COM, and then your red one is going to go into the one that says volts. This is the symbol for ohms, milliamps, and also for a function generator. And essentially, that's the only one you'll ever need to know if you are following the rule of not, using high voltage levels, because what this one is for is this is for like higher voltages and higher amperages. And the reason for that is there's a fuse inside of here. So it has a much higher fuse, but we're never going to be taking any of those measurements. So we don't actually even ever need to change or move our probe over. So now we've got it set up. What I'm going to do is I'm going to set mine. So we need ours on this 20 volts because we are expecting the VCC to either be 5 volts or 3.3 volts on this device. So that's greater than 2000 millivolts, which is essentially 2 volts. So that's why we're going to be using this measurement. And I'll just set this down here. And I do just want to quickly show, so the way that this is just a tip or trick, but generally when I'm working on devices like this, where there's just like a plug and they don't have a switch on them, I usually bring a power bar over to my test area and I plug it into that. And then I use that to be able to turn it on and off without having to unplug it. So before we go and make this measurement, actually, I'm going to hop back over to the screen and I want to show the schematic and also link to the schematic so we can figure out which ones are the TX and RX, so we don't actually have to just probe them all. Okay, so I've got the schematic here. I'll just zoom out. So since the Raspberry Pi is open source, there's a schematic that we can find for it. And this is linked as well in the course. So we'll just zoom back in though. If we take a look at the bottom middle here, these are the header pins here. So this is the one along the right that I mentioned to connect, and then we're not going to be using these ones. And we can see the top 2 pins here. These are 5 volts. And then we have the transmit, the receive, and then we have, sorry, the top 2 are 5 volts. Then the third one, this one right here, it goes down to ground. And then we have the transmit and the receive. So essentially the way that it works is we have 5 volts, ground, transmit, receive. And if you also take a look over at the lectures here, I just make this full screen. There's a picture here that shows it as well. So these are the measurements that we're going to be making. So essentially what the plan is we're going to go and take our measurement across the ground and the transmit pin. And then once we have our multimeter in place and ready to go, we'll flip the power on or plug it in, and we'll take a look for that fluctuating voltage. So one thing that I'm going to do, because it's kind of hard for me to make these measurements and film, and show everything, then I'm actually just going to grab a cable here. So if you don't have these cables, then it's okay. You don't actually need them. You can do it with the multimeter. Just find it a little bit hard to film and show that. So I've got 3 here. So these are just called DuPont cables. So this end here, and we'll be using these later in the lesson. This plugs over those header pins, and then this one just comes out to a male one. And I'm going to measure off of those. And the only reason I'm doing that is just because it is hard for me to take the measurement while filming and everything. So I'm going to connect these 3 over those same. So it went 5 volts, ground, transmit, receive. And I should also call out to just give a heads up. You'll see the lights off on mine, so I have mine powered off right now because I'm working on it. Okay, so for me, purple is the ground, and the red one or the green one is going to be the volt. So if I take a measurement now, and just for a sanity check, should be at almost 0, which mine is. Okay, I'm just going to move this a little bit so we don't get that glare on it. Okay, perfect. So I'm going to power mine up here, and then we should see this fluctuating between somewhere between like 3 and 1. Perfect. So we see it comes to 3 right away, and it's going to hold there, and it's going to take a second before it actually starts fluctuating here. Oh, actually, so I've got the wrong one there. So we just checked the RX pin, so that's why mine wasn't fluctuating. So I didn't realize that these wires are crossed actually, but I essentially just checked the RX pin, which is the green there, and that's why it was at that steady 3 volts because it's just waiting there, waiting for it. So I'm going to reconnect these up here. So for me, it's going to be this purple one to ground, and the blue one is actually the TX pin here. And I'll just power cycle my device here. Perfect. And we should see it come up to 3 volts. And the reason is, and we'll talk about this a little bit more once we're taking a look, but you can see it's fluctuating now. And we see it, we saw a bunch of dips there, and that was a big transmission blast when we saw it dip down. So I'll just do it one more time in case anyone didn't see. I'll power it off here, power it on, and we should see it go up to 3.3 volts, or very close to 3.3 volts. And then when the transmission takes place, which you see right there, that dip, so that's the transmission. And essentially that was a big blast of communication. And our multimeters, they aren't fine enough or precise enough to actually be able to see that whole measurement taking place, like those ups and downs. It's too fast. So that's why we kind of get an average. And then if we just go over, and I'll take the green one here and just show here, we should just see the RX being at a steady voltage. So you'll generally either see it be at 3.3 volts or around that, which mine is, or 0 volts. And you should essentially see nothing happening on this. We're having just very, very small fluctuations that are happening, and that's just because I'm holding this here with my hands. We shouldn't see any big fluctuations like that. So that's how we can go and actually identify that UART with a multimeter. And again, the reason that you would do this is because it's not going to be as obvious on other devices or commercial devices. All right, so I'm just going to hop back over to my computer here, and we'll take a look now at how we can actually visualize these UART connections. Okay, perfect. So the next thing we're going to do is install the software for our logic analyzer, and then we'll take a look with our logic analyzer how to actually make these UART captures and talk a little bit about what UART actually looks like. So what I'm going to do actually is, since we're running a little bit ahead, I'm going to give us a 10-minute break now, and we'll actually take 2 10-minute breaks. So if anyone needs to catch up or has any questions in Discord or anything, I'll hang around and we'll meet back here at 1. And then we'll pick up and take a look at how to capture this UART traffic with our logic analyzer. Okay, welcome back, everyone. So I just wanted to take a quick second here in case anyone does have any questions or they're stuck on something, since we do have a little bit of extra time. So I'll take a look here in the Discord right now. So if you've got any questions, feel free to pop them in the Discord, and I'll do my best to answer them either in the Discord or on. Okay, I'm not seeing any questions in the Discord, so we'll move on here. I will just give a heads up. If you weren't able to get any of the previous things working, or you didn't get your soldering working, or even if you don't have a Raspberry Pi Zero, the next steps, there's some of them that you will be able to do without any connection to it or anything. You can just use my captures. So what I'll do is I'm going to log back in here, and we're going to continue on learning about UART. And what we'll do is we're actually going to learn about the next tool that we're going to be using to actually take a look at these UART captures and be able to visualize them. And that is called a logic analyzer. So we're going to be making use of some open source software through the SIGROC project to actually be able to use a fairly inexpensive logic analyzer. So the one that I have linked in this course, like around $10. And even back when I was in university, like to use a logic analyzer like this, you had to like book special time in a lab because they were thousands of dollars. So it's pretty cool now that we're able to get access to them for $10. So I will just check out their website and quickly show you that website. So if you want to follow along, it's just sigrock.org. And we don't need to download anything from here. We can get it through the app repository, but I did just want to show this in case anyone was interested or you want to learn more about this project. So I'm just going to close Etcher here, and I'll clear this away. So best bet is probably actually to go into the Academy and just copy this directly, but it's going to be sudo apt-get, and then we'll do -y install, and it's SIGROC, and you get it through your app repository. So I already had it, and I don't need to upgrade it, but I'll give a minute here or so for everyone to run this install on your Kali if you don't have it. Okay, so while that's running, if anyone needs to install, I'm actually just going to hop over to my lab desk here, and we'll talk about the Logic Analyzer tool. Also, before I work on my Raspberry Pi, I'm just going to power it off. So just a friendly reminder to do the same thing as well. And I'll bring over my Logic Analyzer. So these are really handy devices, and essentially what they do is they allow us to capture digital communications. So it doesn't necessarily just have to be UART. We can use these for many other digital communication protocols, and essentially they'll just allow us to capture those raw ones and zeros of digital communication. And then the nice thing is, though, we can load those captures into the software, what we'll take a look at, and we can then use the software to actually decode those and figure out what those communications are. So again, this is one of those things where it's probably fairly obvious on the Raspberry Pi what the UART is and what's going on, but it's not always going to be that obvious, and these can save a lot of headaches by just connecting one of these up to the pins and being able to visualize what's there and figure out what communication protocol is going on with it. So the way they work is they've actually got a set of header pins as well, and they should come with cables as well that we can use to connect up. And what we're going to be doing is we're actually just going to connect two cables. We're going to be taking the transmit pin off the Raspberry Pi because we don't actually care about the receive pin. We know nothing's going on that. And what I would suggest is, if you look here, you can see this is like the top-down view of these. So I'm going to use channel 0, which is the top left one for the TX pin of the Raspberry Pi. And then I'm going to put the ground. The ground is the bottom two ones. And really, you could use any channel. The only reason I suggest channel 0 is you'll see there's this little channel 0 here, and there's actually an LED under here. And when it's transmitting or it sees transmissions, it'll blink on and off, and it just gives you a heads up to know that your connections are working and there's actually transmissions coming in. So what I'll do is I'm just going to unplug these DuPont cables that have the male end off of here, and we'll actually only need 2. So just leave the RX unplugged. I'm going to grab a black one for ground and a white one for the TX here. Okay, so my ground one is right here. We'll plug in the ground there, and then the next one is the transmit. Plug this cable here. Perfect. And now I'm going to put my ground. So the bottom 2 are ground. Here's a ground right here. And then this top left one right here, I'll put the white one in. Okay. And then yours should come with this ancient style USB connector here. I think it's mini USB. So plug that in. And at this point, my Pi is plugged in, but it's not powered on. So keep yours powered off. Plug this in here. Okay. And then you should see your power light go on, but the channel 0 should not be showing anything. So we've got it plugged in. I'm just going to double check, make sure those connections are tight. Okay, so back over here at the virtual machine. Again, you may need to do this depending on if it automatically got detected, but I'm going to go VM here, removable devices. Oops, VM, removable devices, if I can use my mouse. And this one is this Lakeview USB device here. So mine, I have it set up to automatically connect to this VM, but you may need to actually go ahead and connect it. If it's showing to connect here, press here and connect it, and then that will show you that it's connected. And one way you can also double check is if you use dmessage. So if you go sudo dmessage, you should be able to see it connected when it came in. So it will be this high-speed USB device using EHC PCI. So that's this device here that we just actually plugged in. Okay, so once we've got it plugged in and we're all set, we're going to launch up the software called PulseView is what actually comes with SIGROC. So if you did that apt-get install SIGROC, you should have PulseView. We'll double click to bring that up here. Perfect, and it's launched up. So the very first thing we'll need to do, if we haven't already, is yours probably is going to show no device here. It's not going to say Slaya Logic. So what you'll need to do is click this drop down here and go connect to device. Under step 1, we have to choose the proper driver. And the driver for that, the driver for the logic analyzer we're using is this FX2 LAFW generic driver for FX2 based logic analyzers. So we'll select that. The interface is going to be USB. That's how we plugged it in. Then we'll just click here, scan for devices. And if yours was recognized, it should come up and it will say this Slaya Logic with 8 channels. So you can click OK. For whatever reason, yours didn't come up, just do a quick double check in your removable devices and make sure that Lakeview is actually connected there. So mine is. Oh, seeing a question here. What was the software again? It is, let me just copy and paste it here. The command for you. That's the software. It's SIGROC. And then the one that we're going to open up is called PulseView. All right, so once we've got all this set up, and yours should look the same. And if you got the device here, then that means that you did it properly. That's really the most important thing. Click OK. All right. Now we need to make a couple other quick changes here before we actually start our capture. So what we need to do is we're going to change the amount of samples. So this is just essentially how long we're going to sample for. So what I'm going to do is I'm going to put mine to about 50 million samples. And then we need to change the frequency that we're sampling at. So essentially what this is doing is we're just taking a voltage measurement very quickly, and that's what's allowing us to detect these square waves of ons and offs. And we are going to need it at a higher frequency than 20 kilohertz. So what we'll do is we'll just take this, and I'm going to set mine to 1 megahertz. So that's 1 million samples per second, and that should be more than enough for UART communication. If you are doing other types of protocols, especially something like SPI or maybe even JTAG, you may need a higher frequency. But for UART, 1 megahertz is going to be more than enough. So we'll click that. And then I'm just going to run through now what we're actually going to do. So you'll recall that most of that UART traffic, it happens at startup. So what we'll want to do is have our device powered off. That's why I said to power it off. And then I'm going to hit run, which is going to start a capture. And then I'll hop over to my desk and I'll plug it in. With the setting we have right now, if you hover it, we have 50 seconds of capture time. So you don't need to be like rushing and running over. We're not going to have that long of a transmission. It's going to be a few seconds. So just hit run, then go over to your desk or wherever you have it, power on your Raspberry Pi, and then at that point we should start to see some messages start coming in. So I'm going to do that right now. I'll hit run. And I'm going to power mine on. I just flipped it on. Perfect. And I can see actually, so all these squiggles here, this is all UART traffic. And once it stops kind of transmitting here, I'm going to hit stop. So I've got this bar at the bottom. This is what's going to allow us to scroll here. And perfect. So we got a nice UART transmission here on D0. So what I'm going to do right now is if you are trying to make this capture and you need a few seconds, then take a minute or two and try and make this capture yourself. However, if you don't have your Pi set up, or you don't have a logic analyzer, or for whatever reason, I'll just quickly go over how to open up a connection. So if you go actually, I'll bring this back over here so we can take a look at the live academy. So if I scroll down to where we are right now, there is this download here. So I already made a capture. So I'll just download this right now actually to show how this works. So go ahead and download that if you want to follow along but you didn't make your own capture. So I'll paste mine here, and then this is going to be double zipped. I had to do this again just to get it working, to be able to put it into Academy. So you can essentially just right click though on it if you want and go extract here. Perfect. So I've got it extracted here. And then what we can do is if I go back into Pulse View, and I'm going to go click this button here in the top left to create a new session here. And then we can click to open up. This button right here allows us to open. And just wherever you downloaded that to, mine was this, I think, where was it? No, it's on my desktop. Here we go. One thing you'll need to do, and this is why mine's not showing up here, is in the bottom here, it says where it says SIGROC session, you need to go all files here. And then we'll want to grab that zip that we just did here. This one, I believe. Okay, so if you grab the wrong one, then it will just show like that. So we'll just try that again. Okay, so this is my capture here, and it does go on for a long time, but if we scroll, I think it's somewhere in the middle here, this is my capture. So you can follow along then with this. It's the exact same thing if you didn't. So I'll just drop back over here to my session one here. And okay, James is saying, if you're on Kali and you ran that apt install, you should be able to get that driver, the FX2 LAFW, through that SIGROC installation. But if you aren't able to get it working, I can help you afterwards and just use the one that I shared previously that you can actually just open up my capture. Okay, so let's zoom in on some of these captures here. So I'm just using the scroll wheel to zoom in here. And essentially what we're looking at here is now just those raw UART transmissions. And what I will do is actually just pull in a decoder. So we are talking about how before we have this software that we can actually use to essentially decode these messages. And so we're not just looking at like bits like this. So we're going to add a decoder. And again, the button for that is this yellow and green symbol here. And we'll search for a UART1. And I just like to drag mine up to the top, which is what I'm doing there to make it a little bit easier for us. You can see here, it's giving us a warning. There is no channels assigned. So what I'll do is I'll just grab and say that the transmit line was D0. And we'll talk about what all these settings mean just in 1 second. The next thing we're just going to go here is change the hex to ASCII. So we'll change the format actually to ASCII because these are ASCII characters that are being transmitted. Now, if we take a look, anywhere in those pink, that's the actual transmission. And if I just zoom out a little bit, we can see we're actually getting some messages here that are during the boot log. So we're actually able to capture those boot logs. It's telling us about the processor, some hashing. So this is all the stuff that we would see in the boot logs. Now, this isn't like the best way to look at this, and generally you wouldn't use a logic analyzer to now actually go through and like parse through and look at these boot logs. We would use a different tool that we're going to use actually later on in the lesson. The reason that we use this is just now we know that this is UART. So now that we have this set up, though, I just want to quickly talk about some of these different properties here. So I'll just scroll over a little bit here to maybe the start of it so we can talk about some of the properties of UART because it's, again, it's one of those things where like it's not always going to be this obvious to identify it. Oops. Perfect. All right, so if we just open up the UART again, see we have all of these different properties. So the very first one we'll talk about is the baud rate. So the baud rate is the transmission or speed at which we are actually transmitting the symbols. So essentially baud rate is the same as a bit rate in UART because we're always going to be having bits be our symbols, but this is kind of the terminology that's been kept over and held over. So you usually hear it called baud rate, but essentially what this means is the bit rate. What that means is if we just zoom in, we can see we have, these are the lowest transmitting widths of a signal. So this is a 1 here, and we have a 1 here, and then we have another one here. What that speed is essentially saying is how many bits per second we could transmit at a maximum amount. And the way that we can actually calculate this is we can actually just bring over this measurement tool. So I brought this right here, and we essentially just need to drag this over the smallest symbol. So for me, I could just identify that by we have all these blips here that are repeating, and these are the smallest ones. So like looking at this one, I can see this isn't the smallest one, but then repeating here, even the zeros. This is actually going to then give us this measurement in microseconds, which is actually going to translate over into that 115,200 baud rate. Generally, on IoT devices, they will almost always be this 115200. Another common one that you'll see is sometimes 9600, but for IoT devices, it's almost always this. So you don't really ever need to set these, but just in case you ever come across and need to measure it, that's how you make that measurement. The next parameter that we'll talk about here is actually the data bits. So the data bits is essentially how many bits are being transmitted per frame. So if we actually take a look here, and we just zoom in maybe a little bit, actually, and I'll turn off this measurement. We've got one frame starting here from my mouse all the way over to this stop bit. And a frame is essentially like, if you're familiar with networking, you would have like a packet per se, which is kind of like the smallest group of data that's going to be in a piece of a transmission. So in UART, we call them frames. And the data bits is essentially telling how many bits of each frame are going to be data. So you're almost always going to see that be 8, because that makes sense. Then we have a byte. As you can see here, we've got those 8 bits. The next one we'll take a look at is the stop bits. So you can see we've only got one stop bit here. So the stop bit is at the end of the frame. And essentially what this is doing is it's telling the receiver that the transmission frame is done, and then we're going to start another one. And then the other one that's not even there, because it's always just going to be, is the start bit. And if I just zoom out here actually to show some slack time, you can see here we have no transmission taking place. There's nothing being decoded. We have this stop bit here at the end, and then it just stays at this high voltage. So in UART communication, when the line is not being used, it's generally going to be held at a high level. And there's a couple of reasons for that. The main one that we leave it at a high level and not at a low level is because then we can actually tell if there's something broken on the line. Like if we're seeing it at 0 volts, we know the other device is off or the line is damaged or something like that. And the other reason is this is what lets us essentially know that a transmission is taking place, is we actually look for that line to be pulled low by that start bit. So that's what we're seeing here at the start of this frame, is the start bit will always just be one low bit. So for us, that's 0. So it'll be 1 0 bit, and that tells us we're starting. Okay, just to take a couple other things here. This usually won't change either. You usually see this LSB first. So this is just saying if we're using essentially the least significant bit first or the most significant bit. Generally, you'll always see it as least significant, but sometimes you need to flip these. And then the last one is that one we changed already, is just that data format. So instead of just being in raw hex or binary, we put ours to ASCII. So yeah, the logic analyzers are a great tool that I use quite a bit, because it allows us essentially to go and visualize that UART traffic and be able to see what's going on. I've had times where I thought something was UART and I couldn't really figure it out. I saw voltage fluctuating and it kind of looked like UART, because other communication protocols that are fluctuating can look like UART. And then I ended up connecting it to the logic analyzer and was able to see, that was a different communication protocol, and I needed to use a different tool to get connected up. Perfect. So as I was mentioning before, we are not actually going to use a logic analyzer to actually go through these logs. If we zoom out, we can see there's a bunch of different log messages coming through here. And these log messages are actually going to be really critical as hardware hackers or IoT hackers to figure out what's going on with the system and allow us to do a lot of recon. So what we'll do now is we'll actually hook up the next tool that we're going to be using and take a look at how we can actually parse through those log messages and talk about some of the important things that are coming through, and also how we can go ahead and get a shell. So I'm going to switch actually over to the workbench now. We'll unplug this logic analyzer and I'll show how we can actually get this connected up and get a shell. Okay, so first thing I'm actually going to do is I'm just going to power off my Raspberry Pi. So I just clicked it off because we're working on it, and then I'll unplug the logic analyzer. So if you do have your cables plugged in, just leave them because we're going to need them again here. And I'll unplug this, and I'll just set this off to the side here. So we're going to be both receiving from the Raspberry Pi, and we're also going to be transmitting to it ourselves. So we'll need to hook up one other pin here. Perfect. And then what I'm going to do is I'll take over the next tool here that we're going to be using, which is this USB to TTL or USB to UART adapter. And this is going to allow us to, in our computer, essentially talk via USB to UART. And so you'll see they're actually labeled on here. It's kind of hard to see, but we have a TX and RX and ground pin. So I'll connect ground for me is the bottom one on here. And then the middle one for me is RX. So I'm actually going to take the TX pin, which is the white one. Again, this is where we need to remember to cross them. And then the RX pin on the Raspberry Pi is going to go to the TX pin on here. Perfect. Now I've got my device still powered off. What I'm going to do is I'll plug this in here. Okay. So I've got my Raspberry Pi plugged in, and you should see probably like one of the lights come on when you plug it in. That is okay. And I'm just going to hop back to my virtual machine here. Perfect. And I will close this. All right, so another friendly reminder, because I sometimes make this mistake myself, go to your removable devices if you just plug this in. Now, if you're using the same one as me that I linked, then it will show up as this Silicon CP2102 USB to UART bridge controller. So I have mine set to automatically connect to this VM, but if you didn't, then you'll need to click the connect here if you're seeing that. And then we'll have to check and make sure it's connected. So I'll just bring this up here. We'll use dmessage, so it's sudo dmessage. And then you should see this CP210X converter now attached. And we'll need to take note of this device number that this is at. So if you're not familiar with how Linux works, if you go like to the dev folder and list that out, and then we can see that we have all of these different TTY devices. So here's this TTY USB 0. So essentially we need to communicate with this device file to be able to actually talk to the UART device. So that's why we had to take a note of what that was in dmessage. So I'll just clear this away, and I'm going to go back to that IoT hacking folder. And the software that we're going to be using to actually interact now with that USB to UART adapter is called Screen. There's a few different terminal emulators you can use. Some other popular ones are PicoCom or Minicom. I use Screen when I'm teaching because I find that it, for the most part, just always works. So unless you are running as root or you've added your user to the dial-out group, you'll need to use sudo to actually be able to interact with that TTY device file. So command to actually get Screen running is going to be sudo, and then it's Screen. And then we put the device file that we're going to interact with. So mine is that USB 0. This will change sometimes. You'll see it like 1 or 2. So just take note of whatever it was. And if it doesn't work, keep in mind to go back and double check that yours was actually USB 0. Then the last argument we need to pass to Screen is the baud rates. We already checked. We know that's at 115.200. So this is why it can sometimes be good with Logic Analyzer 2, is just to verify the baud rate, because we need to know that. So I'm going to hit enter here. And then we see nothing, which is what we expected because our device is actually powered off. So what I'll do now is I'm just going to flip mine on, and then if it's working properly, we should start to see a bunch of communication actually start streaming through. And it will take a second for this all to actually stream through because the bootloader on these Raspberry Pis, it doesn't actually output specifically anything to the UART. We have to wait till it hands over to Linux. And then, so once it's actually, everything's handed over to Linux, you should get the printout that says, welcome to dumb thing here. And if you hit enter, you should be able to get to the root login. So on this device, the root login is root, and then the password is TCM. And then we actually have a shell, so I can run, for example, like who am I? And I'm root. And so now we actually have a UART shell into this device. So before we go ahead any further and do any enumeration or anything like that, I want to show a few things about how Screen works and how to interact with it. And then also we're going to do a little bit more setup here. So you may notice, like if you wanted to read through these logs, like if I use the scroll button as doing nothing other than for us replaying the commands that I have. So what you need to do in Screen to be able to actually scroll up and down is to put it into copy mode. And the command to do that is Control and then A and left square bracket. So you can see that put me into copy mode. Essentially, it's like Control and A at the same time, and then you push the left square bracket. And now I can actually use a scroll bar, or I can use the arrows, or you can even use page up and page down. So again, the command to do that is Control A and then left square bracket all at the same time. And that should put you into the copy mode. And this will also let you take copy of this if you want to like copy and paste anything from here. So I'm just going to scroll actually up to the very top here. And we can see the very first message we get is it's booting Linux. So what's happening here in the boot order is the very first thing that's running on the Raspberry Pi is what's called the primary bootloader, and that's actually just running inside of the CPU itself. It's like a very, very small, minimal bootloader. And then that's actually going to pick up what's called the secondary program loader. And on the Raspberry Pi, it uses its own special one. Usually you're going to see a secondary program loader called U-boot being used. However, the Pi uses its own. So that secondary bootloader is going to then load up into the memory. And then what its job is going to do is actually to bring over the Linux kernel and load that Linux kernel up into memory and set everything up so that the device is going to be able to run. So you can see here, actually, it says it's booting Linux. And just the second message actually we get here is actually some really good information here. So we get the Linux kernel version already, so a little bit of information for us. We could then go out and take a look if there's any vulnerabilities in this Linux kernel. I actually compiled this kernel myself, so you can actually even see here the computer. This is my development computer that I compiled this on. It actually even goes even further to tell us the compiler that was being used, which is nice to know because if we wanted to cross-compile or bring any tools or exploits or anything like that onto it, it tells us the compiler that's being used and even the tool chain for building that compiler. Can also see some details about the CPU. So we see this is ARM architecture, and it's actually using ARM v7. So this is going to be important details, again, if we're wanting to bring over tools, for example. If we scroll down just a little bit more, we see the kernel command line. So this is going to be really important for us to see because this is essentially what is starting up Linux. So the very first thing that's going to happen once the bootloader passes over to Linux is it passes over that kernel command line, and then essentially everything spawns after that. So we can see some details, for example, about setting up the console. For example, here we can see it's on this TTY AMA0 and the baud rate here if we didn't already know that. So we can scroll down a little bit more and we'll just start seeing some more, all of these logging messages about setting up the device. So I'm just going to scroll through until I see some more things that are kind of interesting to me here. see a little bit of details here about the file system. So that's always nice to see when you're looking at IoT devices, is just to get some ideas about the file system. And then we see this line here that is letting us know what the init process is. So essentially, after Linux gets handed over by the bootloader and it runs that kernel command line and sets itself up, it's then going to run the init process, which is going to call a bunch of scripts that we will take a look at. And this init process then is what is going to call those scripts. So it's telling us, where that's coming from. Can then see some other logging here about loading drivers. So we can, and some certs here. So this is for the wireless. And then we actually start to see some of the logging from that's actually specific to the device here. So we get the starting dumb thing HTTP server. So we can actually see it's running HTTP server. We can see actually where this is coming from. So the logging is going as far as telling us the binaries that are actually sending these logs, or the functions that are. So we now know, if we didn't already, that it looks like there's an HTTP server running. We've got this controller that's telling us there's checking for an on-off state, some details about parsing config files. And then, of course, we got to that login back here. So we want to get out of this copy mode. You can just hit Control. And one thing you'll see is, and this happens all the time with UART shells, is the logs from the device are just going to keep streaming out to us. So you can see here we have this controller that's checking for an on-off state and parsing an XML file. And it looks like that's happening maybe on the minute. We can see it repeating. So that's just going to keep coming through our logs. And sometimes they can be very verbose, and they'll actually like print over where you're typing. So something to keep in mind is they're just being displayed though, so they won't actually impact what you're typing. So if you are writing a command and they do like pop up on the screen or something, you can just essentially ignore them, and whatever you type will still be sent without those characters. So what we'll need to do is actually set up the wireless, because that was failing when we were actually setting it up. So I'm going to go back into my shell here, and I'll show how to set up the wireless. So on this device, the wireless info is set in the WPA supplicant file, which if we just run a quick ls, see where we are. Actually, we're in root. So if you go over into the etc directory, there's a file called wpa_supplicant.conf. And what we need to do is we're going to use vi to edit that. Okay, so this is just my lab network here that I have set up for my Wi-Fi. So yours should be showing something else here, but yours will be showing like put your SSID here. So this is my lab network that I have set up, so it doesn't actually go like out to the internet or anything like that. So you need to just put your Wi-Fi and your pre-shared key here, whatever it is. So if you are on your Wi-Fi, just keep in mind, like I have a lab network here that doesn't actually route out like to the internet through it, so I'm not concerned about it, but just keep in mind that yours is going to show that here. And then what you will need to do, so I'm just going to actually get out of here. So I'll hit escape and then type the colon and then Q to quit. And you can see like it kind of messed up our typing there. So try and be quick if you can when you're editing this, or like wait till after the minute so it doesn't screw it up. Or you can just remember to type it. So I'm just going to do this again, though, here. Okay, and then so just change this to what yours is and use I. So to type in Vim, use the I command to actually be able to type. So I'll just put test here, and then I'll scroll down to the pre-shared key, and I'm going to put test. And then we hit escape and then colon and WQ to save. Perfect. Okay. So I'll give everyone a second to do that if you're following along here. And I'm just going to actually set mine back to what I need my test network to be here. So my test word is this. And then if you run ifconfig, you should see that you have an IP address. So I've got mine here. You may need to reboot to get this going. So what I'm going to do is I'm actually just going to run a reboot here. So run reboot to pull that up. Okay, perfect. So what you might see is it actually freeze for a second here, bringing this up, and I'm back in here. Okay, perfect. So what I'm going to do right now is I'm actually going to give about 5-minute break here, and I'll let anyone get a chance to catch up if they need to catch up. So I'll see everyone back here in about 5 minutes, and we'll just do a quick wrap up and show the last few things here. Okay, welcome back, everyone. So I just wanted to give a chance here. If anyone had any questions or were stuck on anything, feel free to let me know in the Discord. I'll give a couple minutes here, and then we'll do a last little bit of enumeration. So if anyone had any questions in the Discord, pop them in now. All right, I'm not seeing any questions. So what I'm going to do is I'm just going to show a little bit of enumeration and then give a little bit of homework um, for folks if you want to go ahead and do some further research on your own before we go into the second section of this course in 2 weeks, where we're going to actually now take a look at using this UART shell that we have and the access that we have to be able to reverse engineer the firmware and find some vulnerabilities in it. So I'm going to go back into my shell here. And of course, this is just like a regular embedded Linux device. So there's going to be a lot of regularities between this and other Linux. So what I'll give you for homework is to just take a look through and see what interesting files you can find. So we've got, a lot of the standard tools that you would have on Linux, like grep, and of course we have find and strings and tools like that. So a couple of interesting places actually to just get started is we saw that we had that init binary that was running. And I just know from experience of the init on embedded Linux that if we actually just go then to etc, cd into /etc here, you can see there is a folder called init.d. So we can go to that init.d file. And if we list it out, these are all of the init scripts here that are actually setting up the device itself. And we can actually go through and read through those and see if there's anything interesting coming in. So we can see, for example, there's one that connects the Wi-Fi. We have one that sets up the GPIO. So I'll just maybe cat out this one that syncs the time. Looks interesting. So if we go and cat that, can see that we have a script here that gets the time from a public API. And in a later, few lessons down, I'm going to show how this is could be a vulnerability, but just something interesting to look at. So we can keep, catting through and take a look at some of these scripts, and we could take a look and do the rest of the regular Linux enumeration that you would generally do on a system. So we're actually running a little bit ahead today, but this is what I have for today. So I will hang out a little bit longer, though, in the Discord. If anyone has any questions, if there wasn't anything they were able to get working, then feel free to ask them in the Discord, and I'll also be here on the stream. If I'm not getting any questions, then I'll probably hop off the stream, but I will check through the Discord. And if you are watching this, as a VOD on demand, just for anyone that's tuning in later, the channel in Discord, it may not still be there, but if you are running into any problems and there isn't that same live channel in Discord, or it's been renamed for a different live workshop, the best place to ask would be in the course chat for IoT. So I'll just quickly show where that is in our Discord here. So there is all of these course chat channels in the Discord, and there's one for course chat IoT. And if you don't have access to that, then you can go to Start Here Academy and then go here where it says join the Beginner's Guide to IoT and Hardware Hacking Support provided. And then you just click this upside down smiley, and then it will give you access to this course chat IoT here. And this would be the best place to ask questions if you need to. And that live channel does not exist anymore because you're watching this in the future. So thank you very much for everyone that tuned in. I'm going to give it like 2 or 3 more minutes here and see if anything comes in through Discord, because I know we're a little bit delayed. But if I don't hear anything back, then really appreciate everyone that tuned in. I hope you enjoyed the lesson and you learned some things.